Hi and welcome to this video on decision tree classifier. I am Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will be able to understand the tree terminologies, understand the mathematical concepts behind the construction of decision trees for classification, learn the purity metrics involved in construction of decision trees. Here is a sample decision tree. Decision trees are used for solving either classification or regression problems. Decision trees help to visualize the logic for the data which we want to interpret. A decision tree creates a type of flow chart which consists of nodes and a set of decisions to be made based on these nodes. Now, let's understand some of the tree terminologies. A graph is a set of vertices and edges which connects a vertex to another through an edge. Tree is an undirected cyclic graph depicting a navigation or a decision made. Root node of a tree is a node with in degree of 0. A child node of a tree is a node which has an in degree greater than 0, which is connected by vertex to another node. A leaf node of a tree is a node which has out degree of 0. Now, let's take a sample data, the existing bank dataset where we have features age, gender and marital status and our target is profitability. Using this dataset, we will have to predict whether the customer is going to be profitable to the bank or not. To start constructing the decision tree, we would need to subset the data set on each input feature. Let's take an example. The input data set we have a total sample size of 10 with 5 profitable and 5 unprofitable customers. Suppose we start subsetting the data set to construct the tree based on age greater than 35, we have a total population of 6 with 4 profitable and 2 unprofitable customers. Age less than or equal to 35, we have a total population of 4 with 1 profitable and 3 unprofitable customers. Further, subsetting the left subtree on marital status, married, we will have a population of total 4 with all 4 being profitable, and marital status single will have a total population of 2 where both of them are unprofitable. Then subsetting the right subtree based on the marital status, for married we will have a total population of 3 with 1 profitable and 2 unprofitable, and single will have a total population of 1 with none profitable and 1 profitable. So, from this decision tree, we can conclude that a customer with age greater than 35 and is married, and the customer is going to be a profitable customer. Likewise, age less than or equal to 35 and the customer is single, which means that the customer is going to be non-profitable. Here we have constructed the tree based on age and marital status. In reality, there could be many such decision trees which can be formed from a combination of features. Here is another decision tree which can be formed where we start splitting by age and then by marital status and gender. So, there could be different combinations of features which can be used for constructing the decision tree. So, this is how our decision tree would look at the root node when we start splitting on age. This is a decision tree when we start splitting on gender to start off, and this is the decision tree we get when we start splitting on marital status. Now, the question is which among the 3 features to be used to start splitting the tree? Which feature produces the best split, whether it is the age or the gender or the marital status? Among these three features, we would need to figure out the feature which results in the best split. The feature to be selected for the split is decided based on the purity matrix. The purity of a node is a measure of imbalance of the classes of the target variable. Lower the purity measure, higher is the imbalance and better is the split. A better split results in a smaller tree arriving at faster decisions. Decision trees can be constructed using either of the below purity metrics. Gini is 1 minus the summation of pi squared and entropy is minus summation of pi logarithm to base 2 of pi. For constructing decision trees, for each split of each feature, the purity metric is computed. We are going to choose the feature which results in lowest value of the purity metric. We are going to continue doing these till there is some stopping criteria specified. Now, let's understand what is that stopping criteria. It can be either the depth of the tree or some improvement in the purity metric or the number of observations in the terminal node. So, these would decide when the tree should stop growing. Let's now construct a decision tree based on the Gini index. Step 1, we are going to calculate the weighted Gini score for every split from each feature of the given data set. We have a total population of 10 observations with 5 profitable and 5 unprofitable customers. Suppose we split on age, we are going to get a Gini score of 0.44 for age greater than 35 and we are going to get a Gini score of 0.375 for age less than or equal to 35. So, computing the weighted Gini score, we get the weighted Gini score for age is going to be 0.41. Likewise, we are going to calculate a weighted Gini score for gender, where Gini score for male is going to be 0.48 and Gini score for female is going to be 0.48 and the weighted Gini score is 0.48 for gender. Likewise, we are going to calculate the weighted Gini score for marital status, which comes to 0.336. Comparing the weighted Gini scores for all the three features, age, which is 0.41, gender 0.48 and marital status, which is 0.336, the feature with the lowest Gini score is considered for the split, which is the marital status. Now, we start constructing the tree not based on age or gender, but on marital status, which has the lowest Gini score. Which means that if we construct the tree based on marital status first, we are assured to get the best possible tree. Suppose we construct the tree using marital status, and for married customers we have the profitability rate of 66%, and for single customers we have the profitability rate of 0%. Now, suppose we want to use this tree to make predictions and the available data with us is only about the marital status. That is, if the customer is married, the prediction is that the customer has 66% chance of him being profitable. Let's construct decision trees now based on the entropy scores. Entropy is given by minus summation of pi logarithm to base 2 of pi. This is the decision tree what we get when we split based on age. The entropy scores for age greater than 35, we get 0.91, and age less than or equal to 35, we get it as 0.81. When splitting on gender for male, we get the entropy scores as 0.97, and for female, we get the entropy scores as 0.97. Calculating the weighted entropy scores for age, we get the value of 0.87, and for gender, we get a score of 0.97. Suppose our data set has only two features, that is age and gender. Considering their weighted entropy scores, the feature with the lowest, that is the age, is chosen to start constructing the decision trees. In most of the cases, a reduction in the entropy scores before and after the split, called as the information gain, is chosen to construct the decision trees. The feature with the highest information gain is chosen to construct the tree. Now, let's summarize what we have learned in this lecture. To construct the decision trees, subset the dataset on each input feature based on the purity metric. Gini and entropy are the purity metrics to construct the decision trees. Lower the purity measure, higher is the imbalance and better is the split. The depth of the tree, the number of observations in the terminal node, and the improvement in the purity metric after every split are the factors for stopping the decision tree construction. Thank you for watching this video.